Okay, welcome to your lesson on air pressure. For today's lesson, I want you to set up your notebook just like this. Remember, we are either taking our notes digitally in Notability or on paper in our own notebooks that we have at home. So set up your notebook page like this. Please, we're going to do this in Cornell Notes style. And your guiding question is, what is air pressure and what causes it to change? Take a moment to write that down. You can pause this video if you need to. So first of all, what is atmospheric pressure? Some of you have heard this word before. You've heard the word air pressure. Certainly you've heard the word pressure before. We're all under what we would call a lot of pressure right now. And so if you imagine yourself sitting way at the surface of Earth down here, and we all know that gas has mass, and so all that air above us has mass, and it's pushing down on us, it's all coming down this way caused by the force of gravity, so it's pushing on us from above. So if you imagine all that mass of all that air in a column right above your head that's 1 meter squared, the total mass of that air is 10 to the fourth kilograms. That's a lot of mass. And so in the last lesson, we learned a little bit about why it is that we don't get crushed. And so today we're going to sort of zoom in on this and talk about why it's important that we know about air pressure and how that air pressure changes, and when it changes, what does that do to our weather? So something that we might want to know as we get further into this, of course, as you go further up into the atmosphere, gravity becomes less and less intense, and also you have less and less particles pushing down and getting crushed by all that mass above it. And therefore, as you go up in the atmosphere, pressure, which is pretty high down here at about 1,000 millibars, actually starts to decrease pretty quickly all the way up through the troposphere, and then kind of levels off and is very low when you go up high. This is why when you're flying in a jet, it's pressurized, because we are used to the pressure of down here, not the pressure of up here. And so another way to picture this, if you are talking about low pressure means, just very basically, if you zoom in to a particle model, and I have essentially what's like a little syringe here, if you could imagine that, and it's a closed system, and so if pressure is low, those air molecules are kind of far apart, and they're not moving super fast, and the air is less dense then. Now, if you increase the pressure to a higher pressure, that means the molecules move closer together, they're moving faster, and therefore the air is actually warmer. And the air is more dense because those molecules are all pushed together. So how do you change air pressure? Well, in a closed system like this with a syringe, you can make the closed system smaller. So if the plunger gets pushed down, making this space smaller, it pushes all those particles or molecules closer together. Again, there's the same number of molecules. The mass of the air is the same. They're just closer together and therefore more dense. But of course, the atmosphere is not a closed system, and so this method doesn't really work when we're talking about real life. So the second method of changing air pressure is the one that actually happens in the atmosphere more often. And that is if you increase the temperature in an open container, so imagine you open this container up at the bottom, if you increase the temperature, the air pressure will decrease. Right? Because we know that when you warm something up, the particles tend to go further apart. And so if you allow, for example, that plunger to move, that plunger will go up because the air will expand. And therefore, the air is less dense, less air pressure. Now, if you cool the air, those molecules get closer together. They're more dense, there's more pressure. And so if we put this into sort of an equation here, if you look over here, increased temperature equals decreased air pressure. And we can look at our model here of the syringe. Less dense air, less air pressure. And inversely, if you decrease the temperature, the air pressure increases because the density of the air is greater. So this is what we would call an inverse relationship. So now let's consider this in nature, because of course syringes can only, our little model can only go so far. So if you have an area of high pressure, say cold, dense air, that's going to sink and move into where warm, less dense air is rising. Because we know cooler things sink, warmer things rise. We've learned about convection before. And so that cold air moves in to where that warm air is, that warm air goes up. We call this area where a mass of one temperature air meets another mass of another temperature air, we call that a front. And we learned a little bit about fronts in the last lesson. So today we were trying to answer this question. I want you to think about whether you've answered it in your own head. What is air pressure and what causes it to change? I hope this has been helpful. Do continue on with this lesson, do the practice, and we'll see you on the other side. I hope all is well.